Hi everybody, welcome to Cumulative Review number 17. This video is going to be numbers 12 and 13. So what this problem is asking you is to find all the zeros of the polynomial. Now, what I've noticed on past tests when grading this, if we do not ask you for plus or minus p over q, a lot of students start to try to factor this by grouping. But grouping only works if you have an even amount of terms, mainly 4. Because this has 5 terms, we cannot factor by grouping, and there's no GCF that we can take out at the beginning. So what we need to rely on is the graph, aka the calculator. And we need to more likely, other than these two, rely on synthetic division in order to simplify my polynomial and then do factoring by grouping. So what I've already done is if I go to my Desmos calculator, you can see that I already graphed the function. You can see the end of it here. It looks like it crosses the x-axis in 2 places at a nice root of 2, and it looks like about negative 2.5, and I'm not 100% sure. So what I'm going to do is take this point of 2, 0, and I'm going to use synthetic division, and I'm going to simplify this polynomial. So I'm going to take 2, divide it into my lead coefficients, and if it has a remainder of 0, I know it's truly a root. So bring down the 2, multiply, combine, multiply, combine, multiply, combine, multiply. Negative 90 plus 90 is 0, which means that this is a root. So what I could do from here is I could factor by grouping, because again, if I look back at the graph, I'm not 100% sure what this is. So let's change this. We reduce it by a degree. 2x cubed plus 5x squared plus 18x plus 45 equals 0. And now that I have 4 terms, I can factor by grouping. And I can take out an x squared here, and I'm left with 2x plus 5. Here, I can take out a 9, and I'm also left with 2x plus 5 equals 0. So I'd be left with 2x plus 5, and I would be left with x squared plus 9 equals 0. And if I set both of these equal to 0, this answer or root would be negative 5/2. And if I set x squared plus 9 equal to 0, I would get x squared equals negative 9. And if I take the square root, my answers are imaginary, plus or minus 3i. So if I wrote my answers as coordinates, we would have 2, 0 from here. We would have negative 5/2, 0. We would have 3i, 0, and then negative 3i, 0 as my 4 roots. I know there should be 4 because the highest degree is 4. Based on the zeros above, write a function as a product of linear factors, not quadratic. So that would mean that my function would look something like this. This root came from x minus 2. Make sure it looks like a 2. This root of negative 5/2 came from this situation. So my linear factor would be 2x plus 5. My other 2 linear factors, 3i, came from x minus 3i, and then this one comes from x plus 3i. So just make sure you don't put this as a possibility, because that is not linear. Number 13, solve the polynomial inequalities. Part A does not have fractions, but Part B does. So for Part A, let's think about factoring. Looks like we have a greatest common factor of 3 and x squared. So if I take that out, I'm left with x squared minus 2x minus 24 is greater than or equal to 0. If I continue to factor this, this trinomial does continue to factor, because as soon as I see an x squared, we must try to keep factoring. 6 and 4, negative 6, positive 4, multiplies to be negative 24 and adds to be negative 2. So my critical numbers, if setting all 3 of these things equal to 0, if I set 3x squared equal to 0, I would get x equals 0 as a critical number, x equals 6, and x equals negative 4. Because my inequality is greater than or equal to, all of these are included. So 0 would have a closed dot on it, negative 4 would have a closed dot, and 6 would also have a closed dot. I know this interval is not perfect, but it gets the point across. What we'd have to do now is check our intervals. So I'm going to pick something within each interval and plug it into the most reduced version here. So I'm going to plug in negative 10 for the first interval, negative 1 for the second, positive 1 for the third, and positive 10 for the fourth. If I take negative 10 and plug it into something squared, that's going to be positive. Negative 10 in here is negative. Negative 10 in here is also negative. So this result is positive. And I want results that are positive because they're bigger than 0. So this interval works. Negative 1. If I plug negative 1 into something squared, that's always positive. Negative 1 would be negative in that second piece. And then plug negative 1 in here, that would be positive. Positive times positive is negative, so that does not work with our situation. If I plug positive 1 in, we get positive, negative, positive. So we get negative again, so this interval does not work. Interesting, this is not the every other situation. If I plug 10 in, we have positive, 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 which result is positive, so this interval works as well. So my answer in interval notation would be the intervals that work are from negative infinity to negative 4 included, union 6 to infinity included. Now technically 0 is also an answer that could work because it'd be greater than or equal to 0, but for the purposes of for this test in the final, this would be our final answer. Last one for this video, part B. We are doing the same idea of checking the intervals, but first we need to know what our critical numbers are. And in order to do that, we need a common denominator and getting these things on the same side. So what I'm going to do is subtract the 1 over 4x minus 5, and that's going to be less than or equal to 0. The reason that's so handy is because if 0 is on the side, it's much easier to check the intervals. So what we have to do is get a common denominator. So this fraction, we're going to have to multiply top and bottom by 4x minus 5, and this fraction, we're going to have to multiply top and bottom by x plus 3. So if we write that more neatly, we'd have 2 times 4x minus 5 over 4x minus 5 and x plus 3 is my denominator pieces, minus 1 times x plus 3, and has the same denominator, 4x minus 5 and x plus 3. These are going to be less than or equal to 0. So I am not going to get rid of my denominator because my denominator has value because it gets critical numbers. So if I push these two fractions together, and I can, they have the same denominator, and the numerator would become 2 times 4x minus 5 minus 1 times x plus 3, which, if reduced, is 8x minus 10. Make sure to distribute the negative, minus 1x minus 3 over 4x minus 5 and x plus 3. I don't know if anyone's wondering why I am not multiplying out the denominator. The reason is I can see the critical numbers from here, so why multiply and have to redo it later? If I keep simplifying the top, we would get 7x minus 13 over 4x minus 5 and x plus 3 is less than or equal to 0. So my critical numbers come from the numerator and denominator. My critical number from the numerator is going to be 13 over 7, and the numerator always goes with your inequality, so this is going to be included. My critical numbers from the denominator are going to be positive 5/4 from this and negative 3. Sorry, the pen is getting tired. And these are not included because nothing in the denominator is ever included because you can never ever divide by 0. So if I bring all this information back up to the number line, my critical numbers again were negative 3, 5/4, and 13/7. 13/7 is a little bit bigger than 5/4, so I put it higher. Let me just double check to see if I have all the correct. Yes. So again, we said that 13/7 was from the numerator, and because we had less than or equal to, this was included. But the 5/4 and the negative 3 are from the denominator, so they are not included because we cannot divide by 0. So now what I need to do is check my intervals. So I'm going to look and see what I have here. In the first interval, I'm going to pick negative 10. I just like negative 10 because it's farther away. This interval, I'm going to pick 0. This one between 5/4, which is about 1.25 in here, The number 1.5 is between this and this. Feel free to check that if you'd like. And then something bigger than 13/7, I'm going to pick 10. And I'm going to plug all of these into my most reduced version, which I'm going to rewrite up here because it's all the way down here on my screen. So my most reduced version was 7x minus 13 on the top, and the bottom was x plus 3, and then 4x minus 5. Okay, so if I plug negative 10 in the top, that's negative. Negative 10, the bottom is negative, and then negative. So this is negative over positive, which is a negative result. So this whole thing is negative. I want less than or equal to 0. So I want negative results. So this works. If I plug 0 into this, I get a negative result in the numerator. 0 here is positive. 0 here is negative. So we have negative divided by a negative, which means I have a positive result. So this does not work. 1.5. 7 times 1.5 is going to be less than 14. So this result is going to be negative in the numerator. 1.5 in the denominator is positive. 1.5 here is also going to be positive. So negative divided by positive is a negative result, which means this works. 10, positive in the numerator, positive in the first in the denominator, and positive here. Positive divided by positive is positive, which does not work. And so my final answer in interval notation, which I'll do in purple right here, is going to be from negative infinity to negative 3, not included, so parenthesis, union, this interval, 5/4 is not included, so it has a parenthesis, but 13/7 is included, so it has a bracket. So here is my final answer for number 13, part B. All right, guys, that's the end of this video. Again, I hope it was helpful. Best of luck studying.